Hello and welcome back to the AndEngine tutorials. My name is Len Payne and today we're going to be taking a look at Tic-tac-toe. In the previous video we built the data model for Tic-tac-toe, which models the rules of the game and how it's stored in the system. Now we're going to look at building the user interface. AndEngine gives us a lot of tools for this side, where it allows us to extend this SimpleBaseGameActivity class and really helps us set up a whole bunch of tools that were not would have been a lot of heavy lifting without using the AndEngine framework. Part of extending that involves implementing three major tools: the onCreateEngineOptions method, the onCreateResources method, and onCreateScene method. So this video will be primarily setting those major methods up within AndEngine and Eclipse. Now, if you'll recall from a couple videos ago when we designed our user interface, there are quite a few important figures that we need, including camera width, camera height, the grid width, and some of the X's and Y's. We'll be referring back to this during the onCreateScene method, but I wanted to refresh it in everyone's memory to recall that we will be making lines on a scene and using touch areas. Now, some of the details are going to be glossed over. In a properly polished game, the interface would size to various screen sizes. This is not a properly polished game. So we're going to make our scene exactly 480 by 480 pixels, which is the size of exactly no screens in the history of computing. But it makes a nice square grid for us to work on, and we'll hold three 128 by 128 sprites with a nice buffer on it. So the first thing we need to do is create a new class that extends the SimpleBaseGameActivity class. It's also going to implement the onClickListener interface in order to use the button sprites. We're going to set up some high-level constants and some class data members as well. So I'm going to pop over to Eclipse and start working with that. So in my Tic-tac-toe package, which we were working on previously, we have that model. Now we are going to add a class. Actually, 1 minute. Before we do anything, we need to make sure that our project properties, so I clicked Tic-tac-toe, went to the properties, and we have to reference the AndEngine library. Very important. Makes things a lot easier for us in a second. So now I go back, new class. Again, my class name is going to be Tic-tac-toe activity. Its superclass is going to be SimpleBaseGameActivity. You see, I just start typing and it filters it in, and it is going to use onClickListener, but there are three options here. There's the Android Content Dialog interface. There's the Android view. We're actually going to use the AndEngine native one that includes org, AndEngine, entity sprite, button sprite. Bam. Make sure that we include the inherited abstract methods, and we're off to the races. So what that does for us is a whole bunch of basic legwork. It creates the imports and the class framework for the basic stuff that we need to do. Now, we need to set some high-level constants. Specifically, up here we're going to make final private integer camera width equals 480, and another one for the camera height equals 480. These are just regular conventional names. These are the conventional names that if we went up to the AndEngine examples, that's the names that they use for their camera heights. We also have two variables called grid width and grid height. These are going to help us subdivide this a little bit later on. Now, we could use static values, but the reason we're using these constants is so that later on, when we want to change, we want to expand this tic-tac-toe activity and rewrite it so that it's, for example, a connect for activity or a checkers activity. I can change my grid height to 6 by 7 or 8 by 8 or whatever very quickly. And I can also change these elements very quickly. Okay. So those are the high-level constants we need. We also need to make instance variables to deal with some of our grid. So the first thing that we need is a private one second. What I'm building this off of is the button sprite example. So if we go to the examples and pop open button sprite example, it will remind me that yes, it is called iTexture region, and I'm not making things up. But while we're here, we're just going to copy those 2 lines of code. Right. So what this is going to allow us to do, I'm going to copy, rename these variables to something a little more personal. mbitmap texture atlas is just fine, but blank texture region seems like a good one. X texture region and O texture region. Now, what a button sprite does, I'll talk about it now. Give me a moment. It allows us to basically pull in an image, an asset, or a series of assets. This button sprite, one button sprite, uses 3 images. The first image is for just the button by itself. The second image is the the first image is the button by itself. The second image is the button when it's pressed, and the third image is the button when it's disabled. So we are going to use that in a little bit. But the first thing we need to do is make sure that we have the correct texture regions set up. Alright. So those are our high-level constants and our data members. The next thing we do is start working on those method stubs. So in the onCreateEngine options, we need to create a camera object at 0, 0 with a height and a width, which quite literally is I can't remember which one comes first, so I'll look over here. Again, the examples are your best friend, so it's width and then height, which makes sense, but you never know. So at this point, the word I'm looking for, Eclipse is it's telling us that there are many options for camera. The one we want is not graphics and not hardware, it is actually the AndEngine camera. So we import that one. And then we're returning a new engine options object. The first option in engine options is whether or not this should be full screen, and it should. The second option is the orientation policy. So this is screen orientation dot. You can see that there are several different options. For our case, I'm going to use portrait fixed so that it stands upright and never changes. The reason we don't want it to change is because when your screen orientation changes based on the sensor, it actually calls the recreate method, and we're nowhere near a point where we're going to be dealing with the recreate method. So we're just going to make sure that it doesn't change. The next step is to build the resolution policy. And the final step is which camera is being used. The only problem it's got is that we don't have that ratio resolution policy imported yet, so we import it. I'm going to hit Control Shift F to clean that up a little bit. So there's our engine options. This is the stuff that needs to happen before the AndEngine can take control. It needs to have a camera that's pointed at a certain amount of space, and it needs to have a series of options set up. Pretty basic. The next step is creating resources. Now we're going to be using a series of 128 by 128 pixel icons to build our button sprites, and these have to be placed in our assets folder. I have uploaded those to Dropbox, so bam. We can download it. It's exactly 32.65 kilobytes, so it's not exactly breaking the bank. Once we open those, we can put those icons into our workspace under the assets folder. You can just drop them into the assets folder, but conventionally the examples in AndEngine use a folder called graphics, GFX. So we're going to drop those into that graphics folder. And you can see now that I've done that, if I refresh my assets, there they are. The next step we have to take in this on create resources is to use these factory methods to build texture regions out of the icons. Now, I can pretend that I know how to do all this from memory, but you guys all figured out by now. I'm looking at the button sprite example code, borrowing what works, and using it. This is, by itself, simply how the job is done. So in our case, we're making texture manager for fairly small textures. And we are grabbing, what is it? Blank icon.png, x icon.png, and o icon.png. So what this code does, the very first line here is that we're using this bitmap texture atlas texture region factory. A factory method is, or a factory class is a class that has a series of methods that allow you to create objects of another type. So in this case we are creating texture region objects. We are using these texture region objects to hold our pictures. Boom, boom, boom. And then building that set of tools, making sure that all of those pictures are there. This does a lot of the heavy lifting for us so that we don't have to really set up quite as much in terms of the actual drawing code. Give it a save. Now, button sprites have some limitations, and we're using them more or less incorrectly now. How a button sprite works is that when it's not clicked, it's one image. When it is clicked, so as you are touching it, it's another image. And then when it's set to disabled, it's a third image entirely. What we're going to do is have it so that the blank image is untouched, the X image is touched, and the O image is disabled. It'll make sense in a minute, more in the next video. But for right now, all you need to know is that we are able to use those images with button sprites. It's a ham-fisted hack solution. There will be a bonus video to expand button sprites to have the possibility of being disabled and two different options. So we'll see that later on. The last step we have to do to get AndEngine working is that in the onCreateScene method, we need to create a scene. This is going to be where most of the calculations for setting up the UI elements happens, and where we draw the lines for the grid. So I'm going to step back a few steps and look at those calculations to make sure that we have what we need. So first things first, find that onCreateScene. quite a few more steps go in there. We're going to right now perform the calculations that this one asks for. So we have, and we need here, x0, 1, 2, y0, 1, 2, touch x 0, 1, 2, touch y 0, 1, 2, so that we can correctly line up both the lines and the touch areas inside of them. So first things first, x's and y's are floats. Instead of just calling them x and y, I'm making them a little more descriptive, but it's line x, line y. And touch x, touch y. Those are the two major arrays we need to have. We also need to make these two pre-calculated values of mid-touch and half-touch. So, well, I know this value is going to be exactly the same. I'm still going to calculate it 2 times anyway. Just because if we change grid width later on, or grid height, that will change the values of mid-touch x, mid-touch y. But it doesn't mean that we have to go through and change all these values later on, because they're pre-calculated. Now, touch width. This is an actual tricky one. We are going to pick the get width out of that actual icon. So whatever width that icon actually is. So this is where things start to get a little responsive, but it's not perfect by any means. Anyway, we're just dividing that by 2. Alright, now we can start assigning values to these guys and these guys. Again, this is xi is camera width over grid width. Times I. So in the case of 0, it's 0. In the case of 1, it 480 divided by 3, whatever that is. Can't think of it off the top of my head, and life goes on. We're going to copy this and change all of our widths to height. Again, we can't do this just as a large block because width and height may be different. I do plan to extend this into a Connect 4 game, and a standard Connect 4 board is 6x7, not 3x3. But since I'm here, and I do have all those values sorted already, we can evaluate touch x to be line x I plus mid touch x minus half touch x. Which is this calculation right here. We can even just call it padding x. To make everything a little bit easier to read. All right. So all that fancy calculations was basically just to find this point, 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 and so on. What do we do with those points? We need to draw the grid lines, lay out the button sprites. To draw the grid lines, we're going to work from that lineexample.java file. We're going to create lines. You'll notice that the syntax for a line is new line xy xy with and this vertex buffer object manager. This is what allows you to draw on a certain thing. So we're going to pop over, go up here, and create that final vertex button object manager, buffer object manager. Right. And then we're just grabbing it from the actual activity, apparently. Now it tells me we haven't imported that, so let's import that. There are several ways to do this. The easiest way is just to have 4 lines, but it's not very extensible. So we are going to create 2 for loops. I don't know why my copy and paste is refusing to agree with me, but it is. Inside the for loops, we're going to make a final line called line. It's a new line with line x I 0, line x I camera height. We're going to give that a width. 4 is a good width. But we're going to actually create a new constant called stroke width now that I'm thinking of it. And now our code's a little bit easier to read. We pass that VBO manager and we're off to the races. Again, complaints, we don't have line, so let's import the one from AndEngine. We are going to attach a child called line to the scene. In this example, this will only create 2 lines, but if we had a grid 16 by 16, it would create 15 lines between them. You'll notice it starts at 1, not at 0. Copy this. And we're off to the races. So we don't need to keep track of these lines. Once they're on the screen, they're on the screen. They are now managed because they've been attached to the scene. They're managed by the by AndEngine, and we don't need to keep track of them any longer. So they can be declared here, attached here, and we never hear from them again. And we can perform a similar thing with the button sprites. So, popping back over to that button sprite example, we can see that the actual act of creating a button sprite is not super difficult. Just to create one, we make a button sprite called button, doesn't matter what it's called. The constructor for button sprite takes in the center X. The center X is not the actual center X. You'll notice that here it takes the camera width minus the texture width and divides it by 2. So poorly named, but long story short, what we want is not the center, we wanted this touch X. The next 3 elements are the faces. So here's face 1, 2, and 3. In our case, this is this dot m blank, this dot m o, sorry, x, and this dot m o. The last thing we send to this, nope, there's 2 more things. We send the VBO manager, and we send this. This is not it means quite a bit more than it lets on. What this is doing is this is declaring the what's the word I'm looking for? The on-click listener. So way up here at the beginning, we implemented the on-click listener from, where to go, button sprite on-click listener. When we are constructing our button sprites, that's how we send it and say this is the on-click listener. Fun times. The next step that we have to take after all that mess is done is register the touch area and attach the child. Then we make sure that we set the touch area binding on action down enabled to be true. For right now, we are going to adapt that code over here. And that creates one button. This one, this line, doesn't need to be reused. These other three do. I'm going to make this a little bit easier to read and wrap all of this into a series of for loops. What we do now is I and J. That will iterate through 9 times and place all of our elements on the screen, as long as we don't make any typos. To ease our way through the what's the word I'm looking for? The resetting of the game later on, I'm going to add right now one more private member, which is an array, a two-dimensional array of button sprites called grid sprite. This is going to make it a lot easier for us to grab those back later on. Okay. So right now we have set up the series of constants to hold camera width, grid width, stroke width, and so on. We've set up a series of instance variables to deal with our graphical resources, and we've set up an instance variable to make our touch areas a lot easier to control later on. We set up our engine so that it is using a camera pointing at a 480 by 480 square. We haven't done anything with this on-click method yet, and that's okay. We have these set up so that we're creating the resources, and that accesses the uses a factory class to access the graphics subpath of the asset folder and just pulls out graphical icons to set up texture regions. These texture regions are used further in the scene to create button sprites. This is all going to make sense in a second. I'm going to hit run now, which is going to start my Android virtual device, and then I'm going to hit pause because running my Android virtual device takes about 4 or 5 minutes. So run Android application, run, and the waiting game begins. I'm going to switch to a pause and you'll see in a second. Come on, pause. If you were paying attention in my earlier video, you'll notice that I completely forgot a step. There is no launcher activity found. The launch will only sync the application package on the device. So while this is running in the background, I actually have something interesting to do. We're going to modify the Android manifest. Work on the application. We are going to add an activity element. That activity points to our good friend, maybe it'll point to our good friend, Tic-tac-toe activity. Attached to that tic-tac-toe activity, we have an intent filter, and attached to that, we have an action. The action, I already skipped by it, come on, is main. We are now going to add a category, and the category is launcher. So now when I save this, boom, we can pop over, see Android is still doing its merry little thing, and I'm going to pause the video again until that's done. Alright, my Android virtual device is up and waiting and ready for me. So you'll remember where we left off, because it was only a second ago to you, that I had set up the intent filter to launch that tic-tac-toe activity. So I have to reinstall. Now that the AVD is up, this just takes a couple seconds. We give it a run, it runs off and does its thing. Uploading again, and we'll watch it happen. And we'll watch it happen, I promise. So right now, what should happen is that we should get 4 lines on the screen, and we should have a series of touch buttons. When I press the buttons, the blanks should turn to X's. That's the default behavior of a button sprite, that it has a regular button, a touched button, and a disabled button. Alright, it says we are starting the activity. I don't trust it. So what I'm going to do is pop over and open Tic-tac-toe. Interesting. Not altogether unexpected. So when I click here, yeah, I skipped a step. Not a huge deal, but a little funny. everything is working okay, but I'm going to modify it a little bit. In the button sprite example, they set their scene background. This is some sort of finicky blue color. We are going to set ours to light gray. In the line example, they set the color for each line, which I did not do, to random colors. We don't want to set them to random colors. We want to set them to a pretty dark shade of gray. That'll make things a little easier to see. The last thing is that we want to make sure that we have this public on click correctly. So we're going to make sure, see what we've got in our public on click over here. Okay. It's got P button sprite, P touch, P touch, P touch, P touch. So we are going to just grab that and place it in here. Okay. What that little piece of code does is that in this onClick method, it creates a new thread that basically pops up a toast that says clicked. This will be another diagnostic to help us make sure everything's working very well. And of course it's angry at me. Because that piece of code doesn't work. Got to be careful copying and pasting within Eclipse, because it will import things that you are not super sure of. Alright, we're uploading the APK again. Installing it. It's been successful and we are starting the activity. You will notice in the background down here, definitely not starting. So let's go start it. We now have a gray background with dark gray lines. And it's catching when I click things. There's a strong possibility that my graphics card is not able to handle the load, but these should be, when I hold them, turning into X's. Life goes on. Long story short, we are able to register click events, which brings us to where our next video will start. So in this video, we set up the engine options and set up the resources, those were the graphical elements, and then put all the pieces together on the scene. In the next part, we're going to tie that data to the user interface. Thanks for paying attention, and have a good day.